I hope the screen is clear, right? You're able to see without any reflections, right? So those who are online, are you able to hear me?
Yes, sir.
Okay. Perfect. So we get started. Please take. Right. I hope you're able to see the screen also. So those who are online, just give me a confirmation.
Yes, sir.
Perfect. Okay, shall we get started? So yesterday we saw the introduction of what is there in your 12th standard. So we saw the introduction, right, of what we are going to, like what are all the chapters that are there. And then we started with the first chapter, which was named as, or which is named as electric charges and fields, right? So just to recollect, the first part that we need to know is the introduction to electrostatics. So this also we have discussed. So what does the introduction of electrostatics tell us? Basically, electrostatics is a branch of physics, right? A branch of physics which deals with charges mainly which are at rest. So if I have to put a question like this, what would be the counterpart of electrostatics? Can you give a name to it? Electrodynamics. That's what your current electricity is all about. Anyways, in this chapter, we are going to discuss only about the charges which are going to be at rest and the way they are going to create a field around themselves so that they can exert a force on the neighboring charges. I hope I'm clear with that point, right? So just to have a recollection of certain important points. So this is the branch of physics which deals with static charges or charges which are at rest accepted. Okay. So in this chapter, we will study the basic phenomenon about static electric charges. That is the charges which are mainly at rest. And most importantly, yesterday I would have told you one important point. This chapter is similar to something else from your 11th standard. It is something similar to gravitation. You will understand once we start the mathematical equations. Okay. So that is why if you see the charges in electrostatics are very much similar to the concept of masses in gravitational fields. Okay. So the charges in electrostatic field are the same or analogous as the masses which are in the gravitational field. Then these charges obviously are going to interact among themselves by applying force on each other. The force can either be attractive or repulsive. That is the case with respect to electrostatics. If you recollect the concept of gravitation, what kind of a force is it? Gravitational force is always attractive. It is never a repulsive force. Whereas electrostatics can be both pulling and a pushing force. Pulling is attractive and the pushing one is repulsive. Okay, having said this, they also possess potential energy because they are able to exhibit a force and that force is able to do some work. Right? They have potential energy, but the main context of potential energy is discussed in the next chapter because the name of the next chapter is electrostatic potential and capacitance. Then we'll discuss. Okay. Next is the ideas that are taken from this chapter are mainly applied in branches of electricity and the concept of theory of atom. I told you about the atoms, right, from your atomic structure. You'll be calculating the radius of the nth orbit, energy, all those things. The basic knowledge is taken from this chapter. Okay, this is the first part. So, having known this already, the next question that we are supposed to ask is, since we are seeing charges at rest, we need to understand what are charges. So, what are charges basically? This also we discussed yesterday. What are they? It is basically the property, intrinsic property of a material. Sorry, intrinsic property of a material by virtue of which it can exert force on neighboring particles. Right? We will see how it works. Okay, neighboring particles. So when you basically say charge, you can also call it as electric charge. So everything is simplified and called as charge. Okay, because charge, if you take it in mathematics, it is related to money. Similarly, if you talk about the charges here, it is related to the electric charges, or you can call it as electrical charge or electrostatic charge. All the three mean the same. So don't get confused. Okay. And the basic symbol that is used for the charge is Q. It is either small q or capital Q also. Okay. And it is given something like this. It is a characteristic of unit of matter that expresses. So this is the basic definition in English terms. So if you look at the basic definition that is given, it is a characteristic of unit of matter that expresses the extent to which it has more or fewer electrons than protons. So yesterday we discussed this concept. Who is going to decide the charge of a particle? It is the electrons. So if at all there is any material, by default it is going to be, by default you take any material, it is going to be neutral unless you disturb it. Right? Neutral means what? Neutral is a basic term. What does neutral mean in terms of charges? Protons and electrons are same, or to put it in simple terms, I can say that the amount of positive charge is exactly equal to the amount of negative charge. So negative charge is the one that is decided by whom? Electrons. So if there are more number of electrons compared to protons, we say that that particular material is negatively charged. If there is a deficiency of electrons taking place, we call it as positive charge. The same thing in chemistry, you learn it as different kinds of ions, anions and cations, right? So it's the different context, but everywhere you need to understand the fact that charges are very important. And I told you in the beginning, right? This chapter is useful for what? Where do we apply it? One is in current electricity and the second is in theory of atoms is what I told you. And most importantly, what happens is, you know about these substitution reactions that take place in chemistry, like organic, nucleophilic and electrophilic substitution, something they say. So there also you talk about electrostatics. And most importantly, you know this concept of dipole moment, right? When you talk about an ionic bond that is taking place in a molecule, you have something called as dipole moment, means H plus and Cl minus. There is something called dipole moment existing. So that also you learn it here. So what happens there is that you would have learned the value in your chemical bonding chapter. Here, what you will do is you try to derive it. We will understand why it has actually come. Okay. So all those things are applicable. So why I'm trying to say and connect it with your chemistry is both are the same subjects. Especially physical chemistry can be connected to physics. That's it. That's why the name is physical chemistry. Okay. So these 2 points we have already discussed. It. Any doubt in this? I hope I'm clear, right? Shall we proceed? So first we understood that we need charges at rest. Second, we try to understand what are charges. The next question that we are supposed to ask is, I've been telling you one thing, that when you take any material, by default it is going to be neutral. Then how do we create charge on the material? So the next question that I'm going to ask is, how is charge produced in the first place? So are you able to see I take this pencil, okay? Are you able to see the electrons? Protons, nothing, right? Obviously, you need a microscope, a tunneling microscope to look into all these aspects, which has higher resolution. So with the naked eye, I'm not able to say anything. I understand that it is not attracting anything else. Okay, I'm doing a basic test, nothing is happening. So I am trying to conclude that this is neutral. Now I want this to have an attractive property or a repulsive property, whatever it is. For that, I need to make it charged. I need to make it charged. Whether I'm going to give it a positive charge or a negative charge, that is subjective. I know the fact that I need to charge this material. If I have to do that, what are all the things that come to your mind? Okay. You want to say? How do you do that? It's not as simple. Okay. Another charge material. How will you charge that material? Okay. Electromagnets, mainly we do not concentrate on charges. Electromagnets need charges to be in motion. Okay, that is one thing you need to have in your mind. And secondly, where do those charges come from is my question. You're almost there, but think about it. So what you told is one of the parts. But before that, how do you create the charge on material? What did you say? Generally, when you rub it, what is going to happen? So there is a possibility of matter getting transferred. So we use the word wear and tear, right? So generally, when you talk about friction, right? Why do you, when you run, why do you say that your shoes will have a wear and tear when you use it for longer days, and if you use it on a rougher surface? Okay, somebody has told the answer. Static electricity. Okay. What is his name? I forgot. Shubham, right? Shubham, can you tell me what is static electricity? What you're trying to talk about? You're using two
So
words.
you told how can charge be generated in an object by rubbing an object against one another, it attracts electrons and thus a charge gets developed in it through static electricity.
Okay, static refers to rest, I understand. Then what is electricity is trying to talk about here? Electricity, which you have learned, is charges in motion, right? Correct. 10th standard, that is the name of the chapter, right? Electricity. Then here, when you're discussing about it, how did you use the word static electricity? You should have either used static, electrostatic, something like that or something. Or we need to have a different term, right? Shubham, are you able to understand what I'm asking?
Yes, sir.
So what you told is right only. Okay, electricity is a very confused term. Many people think that is charges in motion. Electricity basically refers to charges only. Current electricity is the one where you say the charges are in motion. You need to have a prefix. Okay. So having said this, the first thing, you would have seen something like this, right? You're able to generate the heat and all those things. Why does this happen? Obviously, just to give you a hint, because it is happening due to friction. So when there is friction that is going to exist, right? When friction is going to exist, what exactly is the theory that you can give to support your observation? You're saying the material is going to get charged, but what theory will you give? So can I see something like this? Laws of electrons or gain of electrons. So conservation of charge is one of the basic properties. Okay. So what do you mean? What is your understanding of conservation? I'm trying to understand. So conservation basically means something is preserved. It's not lost. Okay. 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 Okay, that's right. So when you do this kind of a process, right, there is, can I say there is slight amount of transfer of matter itself from one to another? Because basically what will happen due to friction, there is a possibility of addition taking place. Means one material will get lost and will get stuck to the other material. As a result of which there is a transfer of matter, but matter basically consists of atoms, and these atoms are in turn going to exchange charges, basically electrons, due to which there is deficiency in one of the materials and surplus in another material, and there is a difference in charge that is getting created. I hope I'm clear, right? Okay, so that is what happens. One of the methods is called as frictional electricity. If you look at the history of it, right, in 6000 BC, Thales was a Greek mathematician. So he was the first person who observed when you take a material called amber and you rub it against another material fur, right? It was observed that amber could attract certain paper pieces. So that is when the first observation started. That was observation. Theory was not yet formed. Theory, we know it in today's generation. Okay. So when this question started, and why did this, when people started questioning why did this happen, and the answer for that was frictional electricity. So basically, now we are getting into the theory of what is frictional electricity. So please write it down. So friction obviously needs two objects to be in contact. It's a kind of contact force, right? So substances which acquire charges on rubbing are said to be electrified or charged. So these are the different terms we use. Okay. So based on this, if you try to give a definition to frictional electricity, what can you say? Electricity, I told you, right? Electricity means what? It is only charge. Okay, don't get confused next time. So electricity produced by friction is what is called as frictional electricity. It's like a compound noun. Okay, frictional electricity. And those charges that you have produced, right? If they do not move, unlike that happens in current electricity, you call it as static electricity. That is why he used the word static electricity. Shubham, what you told is right. I hope you're able to connect the dots, right?
Yes, sir.
Perfect. Okay. So if the charges in a body do not move, then the frictional electricity is known as static electricity. Okay. And the next method is called as charging by induction. So I just need to open the document. This one alone I thought I'll explain from NCERT. Any doubt? Please tell me. Previous slide. Yeah. Please copy it. Okay. I hope this point is clear, right? Shall I move on? Yeah. So the next one, we call it as charging through the process of induction. Okay. So this is what she tried to tell. Okay, charging by induction is a concept that is given here. So now you know how to create charge on a material with the help of a mechanical concept called friction. Okay, with that you are connecting it to electrostatics, and let's say you have two spheres A and B. By default, they are going to be neutral. So when we say neutral, they are going to have equal amount of positive and negative charges. Okay. So let's look at the diagrams and try to frame our own theories and try to read it later. Okay. What is happening in diagram B? There is another material which is, how is it charged? Okay. It's like into Marcus, basically it is a positive charge. So when you try to bring the positive charge closer to sphere A, that is the first sphere. Okay, I'll zoom it. So when you try to bring it closer to sphere A, what do you think will happen? You're bringing it closer, okay? You're bringing it closer. In the previous case, what did you do? You literally touch both the objects. Here, you're not touching it. Okay, so there is something important I'm going to tell you. So you're going to bring it close, and in between medium is there, right? It is supposed to be a conducting medium, so that the charges which is there on the rod is able to interact with the charges inside the sphere. So what is happening inside the sphere? So it has equal amount of positive and negative charge. Now the question is, when this positive charge is brought closer to A, is that A going to lose all the positive charge? What will happen? It will get redistributed. So what do I mean by redistribution? Means more amount of negative charge will get aligned to the left end of A, and the positive charge will get shifted to the right end. So this positive charge that is getting developed. So there are two ways to analyze. Okay, it is not necessary that always there should be a loss of electrons. There can be deficiency of electrons also. So when more amount of negative charge has got accumulated on the left hand side, there is deficiency of electrons taking place on the right hand side. So that can be treated like a virtual positive charge. Need not be an exact positive charge. It is like a virtual positive charge. So what will that charge do to the sphere B which is in contact with it? It will attract the negative charges, and those negative. So when the negative charge is again coming here, what is going to happen on the other end of B? So positive charge is going to get arranged. Now the important question is this a permanent redistribution or is it a temporary redistribution? Temporary, right? Why? Because as soon as you bring out the positive charge, the redistribution is lost. It will try to go back to its neutral state, because any object in this world will try to always be at stable condition, right? If it is unstable, it will start reacting. Now, if that should not happen, so you're able to see a stand at the bottom, right? Now, the question is, why is this charge not flowing to the ground? Because you use an insulation. So insulation is something like this. I told you yesterday, right? The wire, the stand is insulated so that the charges are not lost to the ground, because ground is a good conductor of electricity, right? So when this is happening, once you create this process in step number B, what is happening? A and B are in contact with each other. Now, if you try to slightly separate them away from each other, then what will happen? Then there is something like this that is going to occur, right? When this is going to occur, so let's try to read it out. So in step number 1, what is happening? Bring two metal spheres A and B supported on insulating stands and bring them in contact, right? Secondly, bring a positively charged rod near the spheres, say A, taking care that it does not touch the sphere. That is the most important thing. Okay. They do not touch the sphere. Then what is going to happen? The free electrons in the spheres are attracted towards the rod. This leaves an excess positive charge on the rare surface of sphere B. Both kinds of charges are bound in the metal sphere, and what is happening? Obviously, they cannot escape. What is the meaning of it? They cannot leave in the sense it is not lost to the surroundings, right? Because everywhere you have insulated. So this kind of a system can be called as an isolated system. Have this in your mind, right? It does not have any connection with the surroundings, right? Both are bound in the metal spheres and it cannot escape. Therefore, they reside on the surfaces as shown in figure 1.4b. So other stories I've already explained. In third step, what is happening? Once you start separating the spheres by small distance, while the glass rod is still held near the sphere A, what is happening then? Then what will happen is the two spheres are there, right? They start behaving like opposite charges, means they will try to come close to each other. Naturally, if you leave them, right, they'll try to come close to each other. but you're forcefully separating them by doing what? You're not removing the glass rod. Are you able to understand that? Now what will happen once the glass rod is removed? So fourth step, that is D. In diagram D, if you see, if you separate the spheres by a small, sorry, this one, right? Remove the rod. The charges on the sphere start doing what? Rearrange themselves as shown in figure 1.4b. And now you separate the spheres slightly apart, then the charges on them get uniformly distributed as shown in figure E. So this is what happens. So what did you actually do? You had a system of charges which were basically neutral. So you took another rod and went close to them and you started disturbing the equilibrium condition by creating a redistribution. So here, after doing all these things, by having the rod closer to it, you started separating them. After a certain point, you separated them completely by removing the rod. Then there was a redistribution taking place. Now I can say both these spheres are individually charged. So how did you create? Through the process of induction. So can you tell me what does charging through induction mean? So you are inducing. So in physics, wherever you see the word inducing, right, you do it without a physical contact. That is why if you see electromagnetic induction also it takes place without a physical contact. Okay. So induction, that is charging without any physical contact using these kind of processes is what we call it as charging by induction. And this is one of the important principles which is used in a device called as capacitor, which I told you yesterday. I'm not able to hear. What is he asking? Charging by induction means creating charges on objects without physical contact. Without any physical contact is what we call it as charging by induction. Right. Right. So we saw both the methods. This is a box, a normal box which is given for parcels. So bottom, what I did is I stuck an aluminum sheet. Aluminum is a basically good conductor of electricity, and I took certain thermocol balls. Okay, and certain thermocol balls are wrapped around aluminum coils. Okay, are you able to see what is happening from this side? Is there anything that is stuck at the top? All right. So what I'm going to do is I'm going to take a cloth. I'm just going to try by rubbing it like this. Okay. So I need more force. So one thing, the force was not sufficient, but see. You're able to see something here. So inside I didn't put any glue or something. Actually, what is supposed to happen is when you rub it right, these thermocol balls were supposed to jump and go and get attracted at the top. So what happened initially? Initially, this material was neutral. So the top surface, I started rubbing it by creating some, and I started creating some friction. Right. So what has happened is this top surface has got charged with the help of friction. So frictional electricity is created for the top. Okay. Then what happened to the balls at the bottom is this charge which is created, then it started conducting through this medium, whatever the medium present inside, and it started charging the thermocol balls inside through what process? Through induction, and they started getting attracted. So this is what happens. So this is all about charging. Now, since we understood what is happening in the process of charging, right? The next question that we are supposed to answer is, what are the basic properties of charge that we are going to discuss? So when I say basic properties, I'm not talking about charges get attracted or repelled. So there are certain basic properties that you need to know that is going to exist. Right? So the first property that we are going to discuss about is Quantization of charge. So you have heard this word quantization anywhere? In chemistry, I can give you a hint again, atomic structure. In Bohr's theory, there is something. Quantum mechanics. Yeah. What is that? What do we mean by quantization? You're trying to tell the definition of photons. Light travels in discrete packets, which you call it as photon. Huh? Okay. So quantization, basically, you would have heard. Can you tell me where you have heard this word quantization in chemistry? I'm again giving you the hint. In Bohr's model of atom, you would have told electrons will revolve in those orbits where angular momentum is. You have heard this, right? So that is where the quantization. So quantization basically means, like how you told, it's right. So you need to have an integral multiple of some constant. Okay. So for example, we took this, you take any material, right? If charge is created on that material, we had been discussing from the beginning that electrons are the ones which are going to decide the charge. Right, when you're going to say electrons are deciding the charge, how many electrons are supposed to be lost or gained for you to define a proper charge for that material is what is the concept of quantization. Right. So what I'm trying to say is, if a material, like let's say I take this rod, I take this marker, I rub it against each other. If one is getting positive charge, the other is getting negative charge, then this material would have lost either 2 electrons or 3 electrons. It cannot lose anywhere between 2 or 3. It cannot lose 2.5 electrons, means half electron is stuck here, half there. So that is what quantization mainly says. So if you observe, the first point that they state is the fundamental unit of electric charge is carried by electron and is represented by what unit? Coulomb. Coulomb is the name of scientist. Okay. So E has a magnitude of how much is known to you. So what is the charge of an electron? It is 1.6 into 10 power minus 19 Coulomb. Okay. So this is the basic thing. Now you need to give a statement to quantization. So what does the statement tell us? In nature, the electric charge of any system you take is always what? Is always an integral multiple of the least amount of charge. So what do you mean by integral multiple? Integral is derived from the word integer, right? So it means that the quantity can take only the discrete set of values, and this is the mathematical expression. Q is equal to plus or minus n into E. So you can actually add this plus or minus as a prefix. What does n stand for, guys? Integer, right? So here they wrote it as n as an integer, right? That is why it was not written as plus or minus, but most appropriately you can write it as plus or minus n into E. So what do you mean by plus ne? So electrons are lost. Minus ne is going to be electrons are gained. Integral multiple, not Coulomb, no. Charge of an electron is not exactly equal to 1 Coulomb. So the next basic property. So I hope you guys wrote the heading as basic properties of charge. So under basic property, there are 3 properties. The first one that you saw was quantization of charge. Second one is conservation of electric charge. This word is also not new to you. Conservation. What does it mean? Something is preserved. It's not lost. So if you talk about an electric charge, it can either be created nor destroyed. But what did we do here? It can be transferred from one material to another in such a way that if you take the sum of all the charges that are present, it will always be a constant. It will always be a constant. Okay. So if you talk about the law of conservation of electric charge, the total charge in an isolated system, underline that word isolated. So total charge in an isolated system always remains constant. That is a statement. Okay. So when they ask you, if this, let's say this is asked for 1 mark, don't write the explanation for conservation of energy. charge can neither be created nor be destroyed. That is not what they're expecting. You need to write the statement. What is it? You take an isolated system, the total charge of an isolated system is always a constant. That is the statement. There will be two particles in the system, minimum two particles. See, for example, you take the box along with the cloth. That is the system. So initially this was neutral, this was also neutral. I took the cloth and started rubbing. So this got charged, right? If you take that charge and calculate the amount of charge that is created on the cloth, the sum will always be a constant. That is the meaning. Okay. So this is one of the examples that are given here. That is, you take a uranium-238 nucleus. Okay, it gets disintegrated. So it gets disintegrated into thorium and helium-2 plus, which is basically alpha particles. Disintegrated. Disintegrated means breaking. The nucleus breaks into two nuclei. What are they? One is thorium-234 and second is helium-42. That helium-42 is basically alpha particles. You know about the Rutherford's experiment, right? Alpha rays. So those are helium rays. Okay. So if you take the charge on this particular, like if I have to speak, like reactants and products, right? Calculate the total charge and see. So who decides the charge? So initially, what are the number of charges present in uranium-238? So top one is mass number, bottom one is atomic number. So atomic number is 92. So it had a charge of 92 E. Right? What is the total charge present on the right hand side? 90 for thorium and 2 for helium. So 90 plus 2 is still going to be 92. That is the meaning of conservation of charge. I hope I'm clear, right? Right. The next concept is called as the additive nature of charge. Is there anyone who's copying the previous one? Okay, please write. Done. Moving on to the next concept. That is the last property of charge, which is called as additive nature of charge. The name itself is suggesting. Right. So what does additive nature of charge mean? Even before you look at it, try to define it on your own. So additive nature of charges means if you take two materials, basically charges can be of positive value or negative value. According to quantization, we understood that Q is equal to plus or minus any, correct? So when you try to add them, right, in physics, whenever you are trying to add two quantities, there are two ways to add it. One is using vector addition, or the second is using algebraic addition. Don't use the word scalar addition. What do I mean by algebraic addition? Is algebraic is properly using mathematics of plus and minus. That is the meaning. So if you look at it, charge is what type of a quantity? Is it a scalar quantity or a vector quantity? It has magnitude. For example, charge of an electron is 1.602 into 10 power minus 19 Coulomb. So charge of electron is negative. So just because it has a negative sign, can I say that it is a vector quantity? Because it does not have a direction associated with it, right? So even if a vector has a direction, what is the other important property it should satisfy for it to be called as vector? It should follow vector laws of addition. So first of all, charge is failing in the second case itself. It doesn't have direction, right? So I understood that charge is scalar. So whenever you are trying to add scalar quantities, this is the important point you need to have. What is it? Algebraic sum. So if you talk about the total charge of a system is equal to what? Is equal to the algebraic sum of electric charges that are located in the system. This is again for isolated. Okay. So for example, if I have two objects, guys, one of the objects has charge plus 2q, the other object has a charge of minus 5q, then what will happen if you try to add them? So I am trying to say, what do I mean by adding here is you are not going to literally add and leave it. So what has happened is, this is a charged material. The first material is charged. The second material is also charged. Let's say you're trying to bring them in contact through friction, and you're rubbing it, so that what is going to happen? There will be a transfer of charge that is going to take place. Once you rub them, if you take this material away, let me call this as 1 and this as 2. If I take the first material away, let me say the charge here now is plus 4q. Then what would be the charge that is present here? Minus, how did you get that minus 7q? Because plus 5q minus 5q should be equal to plus 4q plus q dash. The q dash is going to give you how much? It gives you minus 7q. So you understood? Actually, what I'm trying to say here is both are isolated systems only. So this addition of charge is indirectly telling us about the conservation of charge absorption. This is the meaning of the total charge of an isolated system being constant. Now you understood? Are you guys clear? So both mean the same, but they are defined as two different properties. Clear, guys? So how did we go? First thing is we understood electrostatic, then we saw what is charge, then we saw how to create charge, then we saw what are the basic properties of charge. So with this, the charge things are over. Now we need to understand what will happen if you bring two charges close to each other and how are they going to interact. Right? This is where the concept, the mathematical part is going to start. That is lecture number 5, which is basically called as Coulomb's law of electrostatics. So he is the scientist. So the next heading that you're going to write is called as Coulomb's law of electrostatics. Okay. Now listen. So since I'm calling it as a law, that needs to have a statement associated with it. So what does the statement tell us? So you know about gravitation, right? So in gravitation, if two masses m1 and m2 are separated by a certain distance, then how is the force of attraction between them defined as? Directly proportional to? Inversely proportional to? Look at the statement. So when you spoke about point masses. Here you are going to speak about point. So Coulomb's law, the first important point you need to have in your mind is it is applicable only for point charges. So I hope you understand what do I mean by point charges, right? So if the charges do not have a finite size associated with them, I'm not talking about shape. When I talk about point, it doesn't have any shape. So if they do not have any finite size associated with them, then we call them as point charges, right? So it states what? When 2 point charges are separated by a reasonable distance. So what do I mean by reasonable distance? The distance at which they both can interact in terms of force, right? If they are at reasonable distance, then Coulomb's law states something like this: the force of attraction or repulsion between them is directly proportional to whom? The product of, there is one thing, see, the product of the charges. Okay, I would like to add another word, product of the magnitude of charges. Please write down. So please write down the statement alone. So write the heading as statement, put a colon and write it. The force of attraction or repulsion between two what? Point charges. Underline the word point charges. Between 2 point charges. Distance of separation between them. That is one way of understanding. But here the point size may mean they literally point size. So that is where this theory is derived. Okay. Is directly proportional to whom? To the product of magnitude of the charges. Please underline the word magnitude of the charges. I'll tell you why it is so. It is directly proportional to the product of magnitude of charges and what? Inversely proportional to the square of the distance of separation between the two charges. Okay, between them. And most importantly, how will they interact with each other? They will interact with each other along the line joining both the charges. Okay, I'll explain that. So if I take this point charge as Q1 and this point charge as Q2, then how can you write it mathematically? F is directly proportional to magnitude of Q1 into magnitude of Q2. And if I say the distance of separation between them is R and F is inversely proportional to R square, then F is going to be product of Q1 and Q2 divided by R square. Right, a simple thing. Now, whenever you are going to remove the proportionality symbol, what are we supposed to do? So you need to add a constant. Here, the constant that we are going to add is a k, a small k, okay, into Q1 into Q2, the whole divided by R square, where this k is written as 1 divided by 4 pi epsilon naught. Okay, where this epsilon naught is called as permittivity of free space. It's called as permittivity of free space. Okay, what do I mean by free space here? Free space is vacuum. Right. So this value is almost close to that of air also. I'll come to that point. Now, so basically there are two parameters we'll be learning this year. One is called as epsilon naught, which is learned in electrostatics, and the second is called as mu naught, which is learned in magnetism. Okay, this epsilon naught and mu naught have relevance with respect to an important parameter called the speed of light. So we know what is the speed of light, right? In air or vacuum, it is going to be 3 into 10 power 8 meters per second. So C is basically written something like this. You need not worry about what it is. 1 divided by root of mu naught into epsilon naught. Okay, where C is what? So you can write it as a separate box. Okay, so just an extra information. C is equal to 1 divided by root of mu naught into epsilon naught, where epsilon naught is what? Permittivity, and mu naught is permeability. This want you can make a note of the term. Don't worry too much about it at this point. So what is it? Mu naught is permeability. C, speed of light. So you're writing the 3 into 10 power 8 letter. Actually, the back-end meaning of 3 into 10 power 8 is this mathematical formula. We'll learn about this in 8th chapter. So let's not worry about it now. So C is equal to 1 divided by root of mu naught into epsilon naught. So having said all these points, F will be equal to, in the place of K, I can replace it with this parameter 1 divided by 4 pi epsilon naught into magnitude of Q1 into magnitude of Q2 divided by R square. Then the value of this 1 by 4 pi epsilon naught is going to be 9 into 10 power 9. It is a calculated value from the speed of light, which I told you. So 9 into 10 power 9. Can you guys tell me the units of it? Newton? Try to rearrange them. Newton meter square per Coulomb square. So what is the value I wrote here? It is for K, that is the whole value of 1 by 4 pi epsilon naught. But if you take the value of epsilon naught alone, that is going to be equal to 8.85 into 10 power minus 12 Coulomb square per Newton meter square. So these two values you are expected to remember. Am I clear, guys? This is where the mathematics part is going to start. I hope there is no confusion, right? So those who are online, any doubts?
No, sir.
No, sir, can you scroll a bit?
Sure. Will this work?
Yes, sir.
Here, guys, I'll tell you why I wrote magnitude and all. When we solve problems, you'll understand why I'm using the word repeatedly. Okay. So what did we do here? We wrote a mathematical expression for force. Coulomb's law mainly gave us an equation for force that is existing between 2 point charges. Now the question is, force, is it a scalar or a vector quantity? A vector quantity, right? So isn't it our job to understand how to define force in terms of vector form as well? So what you have seen here, that is 1 by 4 pi epsilon naught into q1 q2 divided by r square. This is called as scalar form of Coulomb's law. What is it? It's a scalar form of Coulomb's law, basically a mathematical equation just to solve problems directly. But even problems, they are concerned about the question, concerned about the direction. Then how will you find the direction? For that, you need to know the vector form, right? So I told you one important point here. What is it? The direction of force between the charges acts in which direction? Along the line joining both the charges. The meaning of it is, if I have a charge q1 here and another charge q2 here, so they will not act along this direction or this direction. It will directly act along the line joining both the charges. So that is what you need to do. And these kind of forces are generally called as central forces. So gravitational force is also a central force. So the forces generally which act along the line joining both the charges is what is called as central forces. Central force. No, I'm saying you understood the statement. Are you clear with what I mentioned here? So if at all there is any force in this nature which is acting along the line joining the particles, those kind of forces are called as central forces. For point, you cannot define perpendicular. Perpendicular is defined between lines. Angles are defined only between lines. Clear, guys? Shall I move on to the next part? That is Coulomb's law in vector. So this is the next heading you need to write down. So please write down Coulomb's law in. Please write. Sure. Which one? This one? Okay. Permittivity means. Okay. What do you think? Permittivity of free space, what does it mean? I told you one important point. If there are two charges, right, they are not in contact with each other. So this law talks about a non-contact force. Correct? So if it has to be non-contact, how are they going to interact? They are going to interact through a medium. So what should that medium do for these charges to interact? Should it cooperate or resist? It should cooperate, right? So generally what happens, right? Permittivity, the name is something related to permitting. Right? Permittivity of free space means if you take these two charges and place them in vacuum, then the exact value of force that is going to act between them is k into q1 q2 divided by r square. But what is that k? It is 1 by 4 pi epsilon. Okay. Look at the way the force and permittivity are there. How are they? Are they directly related or inversely? This equation, observe this equation. Observe this one. They are inversely proportional, right? So more is the permittivity of a medium, then lesser is going to be the force. So one of the most confusing factors is people think permittivity means the permission given. It is actually the amount of resistance offered by that medium for the charges to interact. Good that you asked that question. So that is a significance, guys. Nobody will ask you. That is only for your knowledge. Okay, for you to understand what is. It's a property of that medium. That's it. So like how you have refractive index, right, which will decide the speed of light in that medium. Similarly, permittivity will decide how much force these two particles can exert on each other. What I'm trying to say is, let's say there are two charges which are separated by 1 meter. Okay, you put them in air medium. You take the same system and drop it into water. You take the same system and drop it into kerosene. Okay, in every scenario, you can observe that the force between the same charges, same distance of separation, but the values will be different. Why? because that epsilon keeps changing. Epsilon naught is what we discussed. We didn't discuss about what is going to happen in the other nature. That point I'll come later. If I tell now, you'll get confused. So as of now, we'll stick to the permittivity of free space. So in physics, right, you put any symbol with the suffix of a circle at the bottom that always represents vacuum, free space. So that's what same thing, mu naught. That is permeability of free space. That is for magnetism. How well two magnets can interact. We'll see at that point. We'll not worry about it. So I hope epsilon naught is clear. Right? Everyone here? So the last point for the day, that is we need to see how to represent Coulomb's form, Coulomb's law in vector form. Right. So let's say there are two charges. Let's say if it is like a GPS system, they are located at 2 points. Okay, where I will call one of the charges as Q1 and this other one is Q2. And let's say the distance of separation between them in terms of magnitude is R. Now, if I ask you to write the Coulomb's law in scalar form, you guys will be able to write it. K times Q1, Q2 divided by R square, right? But I'm more interested in vector form. So for that, what I'm going to do is, I'll try to define the position of each charge particle with respect to an important point called origin. So origin is basically where both the axes meet. So from this origin, if I take this distance as R1, okay, and if I take this distance as R2, and I put an arrow mark, right? So these two are what? They are the position vectors. So I'll call this as OAB, right? Now what is going to happen? As of now, if I assume both these charges are positive, so use the basic logic and tell me what will happen between them. Will they repel or will they attract each other? They will repel each other. So can I say Q2 will move away from Q1 and the vice versa? So this will have force F and this will have force F. Now the question is, are these two values of F the same or are they different? Difference in terms of what and same in terms of what? Okay. But the answer is, in terms of magnitude, they both are same. But in terms of direction, they both are different. Because what did Coulomb's law state? Think about it. Each charge will exert a force on the other. What do I mean by that? Whatever is the value of the charge exerted by the first force on the second will happen in the reverse condition as well. Okay, that is why the systems are not generally disturbed. They will not tend to accelerate as such unless there is another charge that comes, that you will understand it slowly. So both have same magnitude. Am I clear with this? Right. So this force F, I have circled it, right? This force F, can I say, this is the force experienced by the second particle due to the first particle. So I will give a suffix like this, which I'll call it as subscript, which I'll call it as F21. So if you see this kind of a notation, what will you understand? Force experienced by the second particle due to the first particle. That is the grammar of this particular notation. Then what will I write this one as? F12. That is force experienced by first particle due to second. So the first number represents the charge which is experiencing force. Second one represents which is giving that force. Okay, which is exerting that force, right? So F21 and F12, one important point, they are same in terms of magnitude, guys. Very important point. They are same in terms of magnitude. But what are they different in? Direction. So what is the angle between both? By looking at it, it is exactly 180 degrees. Okay, that's what vectors is going to tell us. Let's see. So if I write F12 in magnitude alone, look at the way I'm writing, guys. Don't just copy it. Look at the way I'm thinking and writing. So if I write, whenever you're dealing with vector quantities, right, first always concentrate on magnitude. So F12 is equal to what? 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Correct? But since I'm trying to write it in vector form, I'll put an arrow mark on top of it. Now it is my job to represent the direction. So that is where I'm going to take the help of triangle law of addition. You guys remember this? this is OA and this is OB, right? If I take an arrow mark in this direction, so since I am saying F12, right? For F12 is acting in which direction, guys? This direction. You're able to understand? So if this is R1, this is R2, then how much will this be? Or else, if I take this as R vector, for example, then R vector is equal to what? R vector plus R2 vector will be equal to R1 vector. Why is it so? Triangle of addition. So what does it state? The sum of two vectors taken in order will be equal to the third vector, which is taken in the reverse order. We shall concentrate. What is it doing? We shall concentrate. So R vector is equal to R1 vector minus R2 vector. Correct? So you remember the concept of relative velocity, guys. Relative velocity of 1 with respect to 2. V12 is equal to what is the formula? V1 minus V2. In a similar way, if I write this R1 minus R2, can I write this as R12? Accepted? Yes or no? It won't accept for my sake. You guys are able to recollect, no? So this is R12 vector. So R12 vector is R1 vector minus R2 vector. And remember, R12 is acting in the direction of F12 vector. So what is the symbol I need to add here? What is the direction, guys? This is R12 vector. How do you write a vector? Vector is a combination of magnitude and direction. Which vector is used to represent direction? Very good. So it is R12 cap. Sharia. Am I clear, guys? So this R square, can I write it as, so okay, I'll leave it as it is. So next step, F12 vector is equal to 1 divided by 4 pi epsilon naught into magnitude of Q1 into magnitude of Q2 divided by. This R square, can I write it as magnitude of R12 square? What is magnitude of R12? R12 is this thing. R vector is what is R12 vector in this case. So whatever is the magnitude of R vector, same is the magnitude for R12 vector. I hope I'm clear, right? And it is R12 cap. Now comes the tricky point, concentrate. F12 vector, I can write it as 1 divided by 4 pi epsilon naught into magnitude of Q1 into magnitude of Q2 divided by magnitude of R12 square into, how do you write unit vector in terms of vector itself? Somebody is telling the right answer. Vector by, correct. So it is A vector divided by magnitude of A vector. Correct? So in a similar way, how can I write R12 cap as R12 vector divided by magnitude of R12 vector? See, whosoever is having doubt with vectors, right? Videos of 11th standard are already uploaded in the app. You can go and revise it. Okay. So I wrote it down. A cap is equal to magnitude of A vector divided by, A vector divided by magnitude of A vector. Why it is so, I have explained it in the 11th standard thing. You can go and see. Okay. So finally, what will you get? F12 vector as it is 1 divided by 4 pi epsilon naught into magnitude of Q1 into magnitude of Q2 divided by magnitude of R12 vector the whole cube into R12 vector. Am I right, guys? Those who are online. Clear?
Yes, sir.
Yes, sir.
Perfect. So what is the important thing you are able to observe in the last step that I wrote? Observe the difference. I wrote it as R12 vector whole cube times what is the vector with which I multiplied? I multiplied with the R12 vector. So there are two equations that you need to remember with respect to vectors. One is this one, and the second is the last step. So what is the difference between both guys? Observe. So the first important symbol that I have put is R square in the denominator, but it is R12 cap. So if it is R12 cap, the denominator is a square. If it is R12 vector, the denominator is is that clear, guys? So using the same logic, okay, using the same logic, you guys tell me what will F21 vector be equal to. This part I will leave it to you. F21 vector is what? I told you in the beginning, it is the same in terms of magnitude. 1 by 4 pi epsilon naught into magnitude of Q1 into magnitude of Q2 divided by R. What will come? It will come as R21 because this will be the direction of F21. So it is R21 vector, the whole square. If I put a square here, I need to put a unit vector. If I put a cube in the denominator, R21 cube, then it will be R21 vector. But you need to understand one important point. What is it? Magnitude of R12 and magnitude of R21 are same. And how much are they equal to? They are equal to the distance of separation between them. So this is an important point you need to make a note. Magnitude of R12 is equal to magnitude of R12 is equal to magnitude of R21 is equal to R itself. Why are not right? Clear, guys? So these are the topics for the day. We have not yet gone into the main context. So with this, we have discussed force also. Charges are over. We understood how the charges are going to interact with each other. Provided we started with 2 charges. Next question we need to ask is what will happen if there are more than 2 charges. For that, we'll go for something called as principle of superposition. And then we'll go to the concept of the name of the chapter, that is fields. So we'll start it tomorrow. Okay. So revise this at come, and yesterday I told you about short notes, right? Start doing it. I hope everybody has written the date on top of it. If you have not written, make a note immediately. So what is today's date? 29th, 29/03/22. Make a note of it and start preparing the short notes. Okay, revise the derivations and come. This is the number. Guys, make a note of it. 6369210899. So this is for new students. 6369210899. This is student support number. So this is the number on which I'll be available. So any academic related issues, you can talk to me here. And secondly, drop a message. Please do not call without prior notice because I might be in classes. I'll respond back within 4 hours. Yes. So that's it. I hope everybody has downloaded the app, right? You have gone through the videos. Any doubt? So there is a YouTube link also where I have explained. I hope everybody received it. Is there anyone who has not downloaded the app? Any doubts? Okay, you can talk to me. You also didn't do it, right? Okay, you're Sanjeevan. Okay. You also didn't do it. So please follow the instructions. There is already a YouTube link for it where you can go through the steps of how to use the app. I told you about the videos, right? Those videos of 11th standard are already uploaded, so you can go through. Okay. So that's it. I'll tell you when I discuss problems. I'll tell you. So as of now, you have this concept of vector in your mind. The vector is the answer for the question you asked. Please tell me. Yeah. Those are online. Any doubts, guys? Perfect. Okay.
Clear,
No doubt
sir.
you guys can wind up. Okay. Right. Done, ma? Everybody is done. So can I close the session? Yeah. Right. Done. Yeah. So those who are done copying can leave, who are not there for the math batch can leave.